Hi, this is Kumar Singh from Designed Analytics LLC, and you're watching another episode of Maverick Mondays. Since last couple of episodes, we have been focusing on the concepts of brain-computer interface with a specific focus on the use case of smartphones, right? I think the whole idea emerged because of a news article around whether or not in future we would have smartphones embedded in our brains, right? So I think in the last episode where we focused more on how these kind of features can be created with existing technologies for disabled people, one of the key things that I wanted to focus on, that I emphasized early on in the episode, was utility, right? Why would we want smartphones for a typical person to be embedded in their brain, right? So as promised in the last episode, today we are going to focus on a typical person and understand why they would need this kind of a feature, function, device, whatever you want to call it, right? So let's try to understand that, right? And let's try to explore that from the perspective of BCI, right? So this morning I actually posted this specific research paper, which is around how a synthetic and artificial skin can have the same kind of, like, in some areas have some features that our actual skin provides us, like the sensory features like hot, cold, things like that, right? And as I looked at it, I think most of my thoughts were around how this can be really useful to people who are disabled, right? Who cannot actually grab something using their hands, right? And then maybe robotics, right? Definitely robotics, as we kind of explore humanoid robots more and more for specific tasks. But even this kind of advanced high-tech technology, I'm not sure how much beneficial it's going to be for a typical human, right? Thinking about smartphones, what are the situations, if you take a step back and try to understand, what are the situations under which you wouldn't want to actually pick up your phone or even like press few buttons on your phone, even if you're texting, right? And text someone on your phone. Why wouldn't you? That's the question, the key question you want to ask, right? And there are use cases that you can make up, and we are going to use one of those to kind of understand how, with some of the existing technologies, right? Some of the existing technologies, you may achieve something like that, but you will understand that achieving something basic that we will actually look into the use case in itself is very complex, and then you need to ask, is it worth it, right? So I mean, that's a question that you need to kind of sit upon for a while, right? Maybe pause the video and try to think, why would a typical person, right? What are the different scenarios in which they wouldn't use their voice, hands, fingers, anything like that, any bodily movement they wouldn't want to use to actually communicate something using their phone? The key here is that I am focusing from the perspective of a smartphone in the communications area, in the communications domain, right? I'm totally encapsulated in the communications domain, right? We are thinking how we can leverage features of smartphone to communicate. Obviously, our smartphones do much more than that, right? But then there are other ways to do those tasks as well, right? So let's first focus on that, because this simple aspect, as we will see in this solution, this simple aspect in itself is so complex to create that having like more complicated features without touching a smartphone or without moving even a single finger is going to be much more difficult, right? So I created this use case in which there are two people from the same company negotiating with another set of people from another company, and this is a very high stake negotiation, right? While the negotiation is going on, one of the say the CEO of the company wants to send a message to the CEO who is actively like negotiating and is currently speaking just the words no, right? To kind of hint, give him a hint during the negotiation that that's not the path we want to take, right? Now, he doesn't want to be seen touching the phone, right? So he cannot reach out for that phone. So most of his, I would say, body movements, even he's not wearing any augmented reality glasses, the futuristic scenario that we discussed in last week's episode, right? None of that. So how can he actually text using his smartphone without actually reaching out for the smartphone, touching the smartphone, right? Is it possible with today's technology? Yes, but again, you would want to question, why would somebody do that, right? So first, couple of things that are kind of good to overview. I mean, I have gone through in too much detail, but this is basically how our brain processes any decision that we make in terms of motion, right? So for example, if you want to just go ahead and pick up your phone, right? It's an intent, right? And there's this whole pathway. There's this very comprehensive process that starts in prefrontal cortex, right? Motor planning goes into motor planning cortex, right? There's this complicated process involved that we do not realize because it happens so fast. As I speak, I move my hands, but there is a process going on that allows me to move my hands and basically point this finger, right? So this process, we don't need to know all of that, but what is more important here is that even before we move, so for example, I see my mouse there on the table. If I want to reach out to that mouse, but I'm just thinking about reaching out to that mouse, so I'm thinking in my mind that I want to reach out, but I'm not actually making the movement. That is an intent. I have an intent to reach out to that mouse, right? What is interesting is, as soon as I think that I want to reach out to that mouse and grab it, my brain actually fires a certain set of neurons. I think they are called PFC neurons, right? They get fired in a specific encoding, right? And that encoding captures that specific intent, and the brain holds that intent. It will hold that intent till I go ahead and grab it, or I decide not to grab it. Then it will let go. Fascinating, right? There's this complexity around it that we do not need to go into the details, right? But that's the key aspect that we need to know. Intent, neurons capture the intent, neurons will hold the intent even if that action has not taken place yet, right? Now, this is how our smartphone screen works. Not very relevant for our discussion, but if you just kind of go through the whole kabuki dance, you will see that eventually the software, through that entire process, captures, okay, what point, which app was touched, right? And it will open and the interaction begins. So it's the iOS, in case of Apple, Android, doing the magic here, right? So touch obviously is just a way to register which software needs to be opened, right? So going back to our neuron thing, right? Here is a real life example, right, of an actual patient, right, that actually benefited from something like capturing the intent, and this is something that's used widely, right? I think Elon's Neuralink also kind of leverages something similar, where using in this case, because the person was disabled, it was invasive, but basically you capture those neurons, right? Those PFC encoding of neurons to understand, okay, what's the intent? So the person doesn't move a muscle, but they think about doing something, right? Now everything that they think about has a unique neuron encoding, like the way neurons get fired. So for example, if you want to move your hand, right, up or down, right, if I want to raise my index finger, it will have a specific intent encoding captured in specifically the way the neurons get fired in the brain, okay? So if you think about our use case, how will it work? Each person who wants to have this kind of capability feature, right? First of all, they will have to wear a scalp with electrodes, non-invasive, but there has to be a electrode scalp, right, on their head. So that's the very first bummer. Would you, as a C-level executive where your executive presence is so important, sit there with a patch on? You will have to probably shave your head, right? So if you are wearing a hairpiece or a wig, then that works. Otherwise, that's the first bummer, right, with the current technology. But say you are wearing that, this particular person is wearing that, and the COO is also wearing that. Both CEO and COO are in negotiations. They both are basically equipped with the device, the gadget, right? So this electrode has captured all the signals intent previously, right? Now, and it has trained an AI algorithm to understand what specific, a few limited set of intents in terms of what specifically this person wants to do with their phone. Stay focused on the phone, right? So as you can imagine, it has to be very specific, right? Because a phone, as I mentioned earlier in this episode, can do a lot of things. Unfortunately, with current technologies, it may not be realistic to train something, a rudimentary setup like this on everything that a smartphone can do, right? So for example, in this case, the intent can be, first intent as you see here is, okay, unlock the phone, right? Open the text messaging app, right? Then you could have either typing through intent, or you could have intent for specific keywords like yes and no. In this, we go with no, for example, right? So each person will have to go through, using this gadget, will have to go through their customized training, an extensive training, where over a period of time, an AI based in the cloud, based on the data captured through the patch on the scalp, will eventually get translated into a comprehensive, restricted yet comprehensive within that restriction categories of intent, right? So it will understand, okay, the user wants to open the text message, unlock the phone, open the text messaging app, choose, say, Charlie as the recipient, type no, right? Now there's this other piece, right? So that's how it can work using the current technology. Okay, now there can be a device, right? Because as you can imagine, since there is no interaction with the screen and the person isn't even looking at the screen, it can be done without an actual screen based smartphone, right? Something like a device, a pendant that the person can wear, or like a box, something like Alexa's and Google Nest of the world, right? But now the second aspect is the other person. How do they receive it? Well, that's relatively much simpler. That very same device, it kind of, and that's something that we already have, right? If you have a bud in your ears and you receive a message on WhatsApp, you get the message, right? Message received from this person, and they read the message aloud to you. So that's pretty much simple. With the current technology, doable, but can you imagine a person going around with all this paraphernalia? Probably not, right? So that's where the practicality aspect comes into play. I created this use case, right? But there are other ways, human ways to deal, right? You can signal, you can gesture like no and things like that. So if you try looking for ways where you actually want a chip embedded in your brain to do all kinds of smartphone work, or smartphone magic, whatever you want to call it, practically it will be difficult actually, right? But in the last and final episode next week, we will actually try to create a solution overview to see if it does happen, somebody still wants to do it, somebody is willing to get tested upon and all things, how will it look like and how will it work? that is something we will cover in the next episode, which will be the last BCI, brain computer interface related Maverick Mondays. In the meantime, have a great day. I'll see you again tomorrow.